So indexes or indices tends to be indexes when you're talking about Oracle for some reason, but the index in a database is a fairly complex topic, so I'm not going to cover everything. It's a good website. I still have it up on this. Yeah, so I like this one. It's a good overview without getting too deep into it. If you look at it's Oracle's blog. Just search for how to create and use indexes in Oracle database, and it gives you a good, simple overview of what's going on in them. But the simple kind of, this is where I upload, by the way, the simple kind of explanation, like the most typical, there's two scenarios I can think of where I've seen them used. So number one, you have a huge, now there's rules about this too. You really shouldn't use indices or indexes on database tables unless they're like huge. That's the whole point. And what you will use them on is things that you search, columns that you search a lot. So keep in mind the primary key is already indexed. It's already indexed. So searches on the primary key will be very fast. But for different, non-key attributes, non-key columns, might not be that fast unless you create an index. So an example is you might search for last names, typically maybe first and last name. You can make an index on both together if you want. But you really shouldn't bother to do this unless you have like a huge number of records. And this is not a huge number, 30-something. I'm talking thousands and thousands. And what it will do is it will speed up. Typically there's two main. There's bitmap is one, and the other is btree. In other words, binary tree. I think all of you've been introduced to Big O log base 2 search times, logarithmic search times, where you get every time you pick whether it's higher or lower, right? You go you reduce the search space by half. That's what's going on when you're talking about B-trees. So that's the default. So, if you have a million things, it still only takes max like 20-something probes to get to the right thing. So you'll create the index based on it. It should be something you search a lot, like a last name, for instance. If you're always searching for last names, or a combination of first name and last name, something you search on a lot, that's what you should use. You should only do it on a huge amount of records. And you should also do it to where it's fairly unique, so you don't have like tons and tons of John Smiths, right? So for instance, you probably wouldn't make an index for this column because it looks like there's only a few separate different, things it could be. But names are, fairly, except for the Johns and the Charleses and stuff, especially if you combine with a last name, you're going to get fairly unique values. So easier to create and more useful to create an index out of that. Something else I wanted to say about it. That's one scenario. The other is something we used at work one time when we were having duplicate stores. I think it was Cricket storefronts, the addresses. The store would get put in a database twice. We were trying to figure out a way to make it not happen. One thing we thought of is like making a unique constraint index. Make a unique index on the address, and what that unique index constraint means is that once you have, say, one John Gray in here, you can't have another one. Obviously, that's not practical for names, but when you're talking about an address, addresses in the physical world should be unique. The only problem is, though, if people like did DR instead of drive or whatever, we couldn't. It wasn't feasible, but it's a possibility. Think about making a unique index constraint. They're not all unique. That's an extra constraint put on it. But the most basic index is going to look something like this. Create index, give it a name, and then say which table it's on and which column. Right, and I think I did this on first and last name before. Let's just double check something here. Okay, I decided I didn't really like the example. It kind of wanted to show what I was talking about. So I did have one on the last name already. I just tweaked this a little bit to make it the first and last name. So create index, name of the index, I for index, right? Employee first, last name. on the table, and then in this case, I'm going to combine these two columns together to make the index. And then you just execute. Sure if this is working now. Oh, again, I do this all the time. I had it highlighted. Let's try it when it's not highlighted. There we go. So, Lord. So index, we create this. So what this means is that now for this particular table, whenever you search on the first name and the last name, you'll get quicker results. Now, again, there's only 30-something records in this, so this is not something you would do for this particular table if it was a real table. You only want to do this when you have huge databases. But also keep in mind that primary keys are already indexed, so if you're searching by those, I don't know how often that happens. It could happen in your code. Like if you know when you're writing your code and you have knowledge of the back end, the database side in your, like say your Java code, you might actually search on the primary key. So that it would make things quicker that way. But if you really, if you're just a random person who was like, who had access to like maybe an actor database, you would want to like have an index on the first and last names because that's a lot of records, a lot of actors, and fairly unique, not as unique as you maybe want, but first and last name together is fairly unique. So I should say fairly. A thing is either unique or it is not. You can't have fairly unique, but closer to being unique. Let's put it that way. And that's indexes.